Hi everyone, I hope you're doing well. So in this video we're going to discuss Leetcode problem of the day, and today's problem is find polygon with the largest perimeter and it is a medium level problem. So I guess this problem was there a couple of contests back in the weekly or the bi-weekly contest, and this problem basically says that we have been given an array of positive integers nums which is of size n, and we have been given the definition of a polygon. Now a polygon has at least 3 sides and the longest side of the polygon is smaller than the sum of its other sides, right. This is what the definition says. Now we have been given the task to find out the perimeter of the polygon or the maximum perimeter of the polygon. So the perimeter they have defined as the sum of lengths of all the sides, and we just have to find the largest perimeter possible. Otherwise, if it is not possible, we just have to return -1. So let us take any general example. If I take this one, the answer is coming out to be 12 in this particular case, right. So this is our sample test case. Now if I just try to sort this particular array, we have 1, then we have 1 again, then we have 2, then we have 3, then we have 5, then we have 12, then we have 50. I believe we have covered all the elements. So we have 1, 2, 3, 4, 5, 6, 7 and 1, 2, 3, 4, 5, 6, 7 elements, right. Now I have sorted it. You will realize in a while why I have sorted this particular array. Now you can take any element from this particular array starting from this particular position, right. Let these be the sides, and you can take any element starting from this particular position. Now if the sum of all these smaller elements is greater than equals to or greater than my largest side, so if I pick any elements and I take all the other elements smaller than it, then naturally this number is going to be my largest side, right. So let me reiterate this part again. If I take 5 as one of the sides, and if I take all the other elements that are smaller than it, then this particular number is naturally going to be my largest side, right. Now I want the sum of all these remaining elements to be greater than my largest side, right. So let's say my sum, I have some sum, it should be greater than 5. Now for obvious reasons, if this current sum does not satisfy this condition, there is no point in removing any of these elements, right. So basically what I am trying to say is, if sum is less than equals to 5, this particular sum, it is not less than equals to 5 in this case, but let us just assume that there were some nodes or there were some values so that the sum was less than equals to 5 after considering all of these values. Now there is no point in removing any of these elements because that could just decrease the sum, not increase it, right. So basically whenever you pick a node, let's say I pick 12 now, so it is always in my benefit to take all of these elements as the other sides and maximize my perimeter or maximize this sum as well, right. So now the question has been reduced to a very simple problem. What you have to do is you have to go through all the values starting from the third position or the second index if you are taking zero based indexing. What I have to do, and very first of all, like why do I have to start from this index only? So that there are at least 3 sides, right. If you take the first 3 elements, that will make the 3 sides. Now what I'm going to do, I'm going to go through all these elements. Let's say I pick up 3 as the largest side, then I'll have to take all of these elements as the smaller side. I take their sum, that is 2 plus 1 plus 1, that is 4. So 4 is greater than 3, that means this is a valid polygon. So what is going to be the value of my perimeter? That is going to be 4 plus 3, that is 7. Now I move on to the next element, that is 5. So I take this particular 7, that is the sum of all of these elements. Whether 7 is greater than 5, yes it is greater than 5, then that means I am going to update the maximum value of my perimeter as 7 plus 5, that is 12, right. So this is how this problem works, and this is how you can easily solve this problem by just sorting the array. Let me tell you why did we sort again. So we sorted the array, so whenever we pick an element, we'll get all the smaller elements on one side, and this can be considered as the largest side. So now what I can do, I can take the sum of all of these sides and make sure that it is greater than my current largest side. If it is greater than, then well and good, I'm going to update my answer. If it is not greater than my current largest side, that means this cannot be a valid answer and I will just move forward, right? So again, I'm going to take all the sides. Why not take a subset of them? Because taking a subset will only reduce my sum, and if my sum gets reduced, it may or might not satisfy my condition. So it is always beneficial to take all the elements so that it is in the higher chances to satisfy this particular condition where sum should be greater than my largest element, right? So I've discussed all the things related to this particular problem, all the reasoning behind it. Now let us have a look at the final code. So what I've done is I've sorted the whole initial array, nums array, which have been given to us, and I've taken the value of n to be nums of size. Now I initialize my answer with -1 and I take the sum of prefix sum. So this pre is prefix sum as nums of 0 plus nums of 1. That is the first two elements. I start from the second position. If pre, that means the prefix sum, that means all the sum of all the elements up until this particular point, not including the index I, is greater than my nums of I, then I'm going to update my answer as answer comma pre plus nums of I. So pre is going to be the sum of all the other edges and nums of I is basically the sum of the current edge. And in any case, if this gets satisfied or not, I'm going to move on to the next line, this particular line, that is pre plus is equals to nums of I. So that now I include this particular index inside the size of all the other sides, so that I can compare it with the next largest side. At the end, I can just return my answer and this would be my final solution. So let me just quickly submit this and show you that this particular code works and this solution is absolutely correct. So you see, this passes all the test cases and this solution is correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video. Don't forget to share thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.